The night sky, inexpressible grandeur, especially realizing that typically billions of luminous stars, sometimes as many as 1 trillion luminous stars, combine to form a single gravitationally bound galaxy. And there may be more than 100 billion galaxies in the observable universe. Galaxies usually occur in the spiral shape, or the barred spiral shape, although there are exceptions. That so many galaxies occur in such limited but well-characterized shapes suggests a common and relatively simple origin. But astrophysicists are clueless. Why? Because astrophysics has been built upon a flawed foundation since the 1930s, as I have described in the video, Lighting the Stars. In the present video, I point out that flawed assumption and briefly review my concept of stellar ignition. Then, I place seemingly unrelated observations into a logical sequence so that causal relationships become evident, making sense of the observed galactic structures and pointing the way for future discoveries and advances. By 1938, the thermonuclear fusion reactions thought to power stars were reasonably well understood. Those reactions are called thermonuclear because temperatures on the order of 1,000,000 degrees Celsius are required for ignition, and were thought to be attained from the gravitational collapse of dust and gas during star formation. That 1930s concept of stellar ignition has persisted to the present, although clearly there were indications of a serious problem as early as 1965. The fundamental implication arising from that flawed assumption is that stars automatically would ignite during their formation. In other words, all stars are luminous stars. I disagree. Post-1930s discoveries lead to a different concept with different implications. First came nuclear fission atomic bombs, and then came thermonuclear fusion hydrogen bombs. Every thermonuclear fusion hydrogen bomb is ignited by the high temperatures produced by its own nuclear fission atomic bomb. Every detonation of a hydrogen bomb is experimental proof that nuclear fission chain reactions can ignite thermonuclear fusion reactions. A star is like a thermonuclear hydrogen bomb held together by gravity. In 1994, I published the idea that stars, like hydrogen bombs, are ignited by nuclear fission chain reactions, and not during formation by heat from the collapse of dust and gas, as had been thought since the 1930s. That scientific article, published in the Proceedings of the Royal Society of London, pointed out that stars without heavy fissionable elements such as uranium would be incapable of igniting and would remain dark. Dark stars, I suggested, are an important component of dark matter, especially dark matter associated with galaxies. The spiral morphology of a rotating galaxy is dynamically unstable. For the spiral to be stable, astronomers have deduced the necessity of an invisible spherical halo at least 10 or more times as massive as the luminous stars of the galaxy. Little is known about what takes place at the center of the galaxy, where stars converge to form a massive galactic core, except that highly energetic events occur, including the ejection of matter in the form of jets, either single jets or bipolar jets, which shoot out in opposite directions. This jet has a length of 4,000 light years. This one, a length of 10,000 light years. This jet has a length of 865,000 light years, long enough to reach another galaxy. Galaxy centers appear to have the necessary pressures for producing highly dense nuclear matter and the means to jet that nuclear matter far out into the galaxy. I have suggested that the galactic jet seeds the dark stars which it encounters with fissionable elements, providing the spark to turn dark stars into luminous stars. Imagine a more or less spherical, gravitationally bound assemblage of dark stars, a not yet ignited dark galaxy. Now consider the galactic nucleus as it becomes massive and shoots its first jet of nuclear matter into the galaxy of dark stars, igniting those stars which it contacts. How might such a galaxy appear at that point? It would appear, I believe, quite similar to this galaxy, where the luminous stars show the path of the jet. Or quite similar to this galaxy. Jet-like distributions of luminous stars are common features of galaxies. The arms of spiral galaxies, such as this one, possess morphologies which I suggest occur as a consequence of galactic jetting of fissionable elements into the galaxy of dark stars, seeding the dark stars encountered with fissionable elements, thus making possible ignition of thermonuclear fusion reactions. Bipolar, jet-like distributions of luminous stars are common features of barred galaxies like this one. Again, I suggest the consequence of seeding dark stars with fissionable elements delivered by the bipolar galactic jets. The structures of just about all luminous galaxies appear to have the jet-like luminous star features, the imprint of the galactic jets which gave rise to their ignition. Therein is the commonality connecting the diverse range of observed galactic structures in elegant simplicity and the causal relationship which appears to exist. And what of the dark matter necessary for dynamical stability? The dark matter is the spherical halo of unignited dark stars, located just where it must be to impart rotational stability to the galactic luminous structure. There is much unknown about galaxy centers and galactic jets. I have just parted the curtain a bit, providing potentially important understanding which may lead to new investigations and to new discoveries. Science is about discovering the true nature of Earth and universe and sharing that knowledge with people everywhere. That's what I do. My name is Marvin Herndon. I hope you have enjoyed this video and that you will wish to visit nuclearplanet.com for more information and references.